Subject section 1.2. So let's go ahead and cover exercises 1 through 4. So in exercises 1 through 4, we want to identify the type of data being presented. It would either be quantitative, discrete, quantitative, continuous, or qualitative. So it's going to be either of these three options. So for number one, well, the question says is the data or the number of machines in the gym. You sample five gyms. One gym has 12 machines. One gym has 15 machines. One gym has 10 machines. One gym has 22 machines. And the other has 20 machines. So since we're talking about some type of number, we're going to be talking about quantitative data. Okay, now the real question is what type of data is it going to be, discrete or continuous? So I have a bunch of machines in the gym. It doesn't make sense to have half a machine or a quarter of a machine or a decimal of a machine. Machines are just one whole machine. So it's going to stop at some point. It's a whole machine. So this would be discrete. Okay, let's go ahead and look at number two now. The data are the areas of lawns in square feet. You sample five houses. The areas of the lawns are 144 square feet, 160, 190, 180, and 210 square feet. So we're dealing with numbers again. So this is going to be quantitative. And then the question is it discrete or continuous? So these are whole numbers, but when we think about square feet or feet in general, it can always be reduced to some type of decimal. It could be reduced to an inch. It could be reduced to smaller than an inch. It could be increased to a mile or along those lines. So it could always, it's never ending. So what it can be is continuous. Okay, so number three is the data are the colors of houses. You sample five houses. The colors of the houses are white, yellow, red, white, and white. Okay. And there's no numbers involved. And so what we're really checking out is just the category of color. So what this would be is qualitative. And number four is the number of cars in a parking lot. So we would just be counting the number of cars in a parking lot. Cars are whole. It wouldn't make sense to have half a car or a third of a car. It's just going to be one entire car. So once again, we would have quantitative, discrete. Okay, so let's go ahead and move on to number five. Five has a couple parts, A through E. So a study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What is a type of sampling in each case? So we would either have a simple random, a stratified, systematic, cluster, or convenience. So let's go ahead and look at letter A. So letter A says a sample of 100 undergraduate students is taken by organizing the students' names by classification and then selecting 25 students. So since we are organizing students by their class rank, freshman, sophomore, junior, senior, and we're selecting 25 students from each, this would be an example of a stratified sampling. Okay, let's go and look at part B now. A random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with the student, every 50th student is chosen until 75 students are included in the sample. So since we are taking every 50th student until we reach a certain point of 75 students, this would be a systematic sampling. Okay, let's go ahead and look at part C now. Part C is saying a completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So since every student has the same chance of being chosen, this is going to be a simple random. Okay, so now moving on to part D. Part D states the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, 4, respectively. A random number generator is used to pick two of those years. All students in those 2 years are in the sample. So since the class ranks are numbered 1 through 4 respectively, and a random number generator is used to pick two of those, that means that this type of sampling would be a cluster. Moving on to part E. An administrative assistant is asked to stand in front of the library one Wednesday and ask the first 100 students he encounters what they paid for tuition. Those 100 students are in the sample. So because this is just the easiest way to do it, the assistant is just standing outside the library, picking the first 100 people he or she sees, he sees. This is very convenient. So this would be a convenience sampling. Okay, so last question is number 6. This question states, a local radio station has a fan base of 20,000 listeners. The station wants to know if its audience would prefer more music or more talk shows. They ask all 20,000 listeners an almost impossible task. The station uses convenience sampling and surveys the first 200 people they meet at one of the station's music concert events. 24 people said they prefer more talk shows, and 176 people said they prefer more music. Do you think this sample is representative or is characteristic of the entire 20,000 listener population? For me, this sample is not representative. So this sample is not representative of the population because it essentially is a convenient sample. So what the radio station did, so the radio station sampled listeners that attended the music concert and does not get the opinions of listeners That did not. Go to the concert. So it's just convenience sampling is not representative because the radio station asked people at a concert whether they prefer more music in concert or talk shows. And of course, the people who were attending a music concert would prefer more music than talk shows. So it doesn't represent that talk show population much, which re which ends in a not representative sample. But that's it for number six, and I'll see you next time. Thank you.